Fourth day of Chapter 3. Here we are with some more 3.3, and we're trying to do more with this first derivative test yesterday. And remember, first derivative test is going to help us find relative extrema. It's supposed to be the idea. So I've got this function, and I might need a little bit more room, so I'm going to zoom this in just a little bit so I've got some more space. Find the extrema and sketch this thing. So remember extrema. I look at it first. I look at this equation, and I can tell, according to this graph, that I've got a vertical asymptote at x equals 0. So I know I am not going to have a value at x equals 0. Let's just make note of that right now. Now, as far as derivative goes, I kind of cheat a little bit. I'm going to rewrite this original function. Let's call it x squared plus 1 over x squared, or x squared plus x to the negative second power. Just because I'm looking at it, and if I got to find extrema, we know first derivative test says we're going to have to take the derivative. Well, I like taking the derivative of that. So here's my derivative, f prime of x. How about 2x minus 2x to the negative third, or 2x minus 2 over x cubed, or how about, let's multiply this thing by x cubed over x cubed, 2x to the fourth minus 2 over x cubed. So where do I have potential maxes and mins? Well, horizontal tangent, we did this the other day, or we've been doing this a lot. Horizontal tangent, let's set the top equal to 0. 2x to the fourth minus 2 equals 0. 2x to the fourth is equal to 2. X to the fourth is equal to 1. Watch out for that plus or minus monster right there. So we got two potential critical numbers there. Vertical tangent, we'll set the bottom equal to 0. X cubed is equal to 0. X equals 0. So I've now got my value set up. I know what's going on. I know I have something going on at x equals negative 1. I know I have something going on at x equals 1. And I know I also have something going on at x equals 0. But as I look at what's going on with x equals 0, we've already said there's a horizontal a vertical asymptote there. So there can't be a max or a min. So let's make our intervals. So my intervals, how about negative infinity to, what's my lowest critical number? My lowest critical number would be 1. 1 to my next value, so 1, sorry, this is negative 1. Negative 1 to my next value, which would be 0. And when you make your intervals, you have to include all the critical numbers, which in this case means even though we know there's not going to be a max nor a min at x equals 0 because of the asymptote, we have to include it as far as behavior of a graph because it could be important to us. So here's 0, and we're going to take that on to, let's fill these in, on to 1 and 1 to infinity. Now we're going to pick our test values. So test values are nice. How about negative 2? How about negative 1/2? Darn it, we got to use a fraction, 1/2 and 2. And now let's take those test values and let's plug them into f prime so that they can tell us something about my function. So take negative 2. Let's look at this function critically. If I'm going to go all the way back to the original version of this function. If I take a negative number and raise it to the fourth and add 1 to it, it's going to be positive. If I, and actually, you know what? Let's cheat even more. Look at the bottom of that original fraction. That bottom of that original fraction is being squared, which means it's always going to be positive. So when you're testing your values in, oh, I'm sorry. Let me say that well. We're going to test this in the derivative, not the original function. So we're coming here to this value of the derivative, and let's see what we got going on. On the bottom, if you put a negative there, it's going to turn out negative. If you put a positive there, it's going to turn out positive. So let's keep that in mind. On the top, x to the fourth. So negative 2 to the fourth times 2 is going to be a lot bigger than 2. So the top's going to be positive and the bottom's going to be negative, which means my derivative is going to be negative. Plug in negative 1/2. Negative 1/2 to the fourth power and doubled is smaller than 2. So negative 1/2 to the fourth times 2 minus 2 is going to be a negative result on the top, negative result on the bottom, positive result overall. Plug in 1/2, negative on the top, positive on the bottom, negative overall. Plug in 2, positive on the top, positive on the bottom, positive overall. What's that tell us about our function? Decreasing, increasing, decreasing, increasing. And no, they won't always alternate, but I hope they will because it makes things a little easier. So there's my intervals. What did I just find? Well, it looks like at x equals negative 1, the function's decreasing and then increasing. So I found a relative minimum at the point negative 1 something. We'll find the something in a minute. At x equals 0, this is what could be a little misleading. You could look at this and go, oh, I've got a relative maximum because the function's going from increasing to decreasing. But remember, we found out that this was a vertical asymptote at x equals 0, so it's not a max nor is it a min. at x equals 1, we're going from decreasing to increasing. Here's another relative minimum at the point 1 something. So let's go back to our original function. In order to find out what those y values are, we're going to have to do f of -1. So my original function said -1 to the 4th, which is 1, plus 1 is 2, divided by -1 squared. So we've got 2 divided by 1, which says that f of 1 is going to be 2. Plug your 2 in there. We've got the same thing going on here. If you plug 1 in, you're going to get the exact same value. So let's come up and let's graph this thing and see what it looks like. So if we go to graph it, I've got a relative minimum at the point -1, 2, and a relative minimum at the point 1, 2. So I don't know much about this graph, but I do know what it looks like around asymptotes generally. So my best guess is this graph's going to do something like this, because it can't go any lower, and it's got to kind of hug that asymptote. It's got to get close to those asymptotes and head off toward, looks like positive infinity from both sides. So there's what your graph looks like. So there's my best, the best I can do with that graph. What's happening outside -1 and 1, I don't know, but I know those values have to be higher than y values of 2, because those are told to us, or those were discovered by this information we found in this chart to be relative minimums. Down here on the bottom, what do we got going? Given here's what we got. We're given some stuff about f prime of x. We're given that the derivative of f is negative on the interval from -infinity to -2, and it's positive on the interval from 2 to infinity. Fill in the appropriate inequality symbol. Here's what I would do. Q prime of x is 2 times f of x plus 3. Well, let's do this derivative. What is q prime of x? How about 2f prime of x, and the derivative of 3 would be 0. So all I did is I just did a simple derivative there. 2 times f of x, its derivative would be 2f prime of x. So q prime of 4. Q prime of 4 would be 2 times f prime of 4. Well, f prime of 4, which interval is that in? F prime of 4 would put us in an interval where the x's are greater than 0. I'm sorry, it would put us in the interval where the x's are greater than -2. So if it puts us in this interval, that means my derivative must be positive. So that would mean that this turns out to be 2 times a positive number. So that would mean q prime of 4 would have to be a positive number. M of x, if I do the same thing, m of x is 4 minus f of x. M prime of x, then, let's see, derivative of 4 is 0. Derivative of negative f of x would be negative f prime of x. So if I wanted to do m prime of 4 would be negative f prime of 4. So let's go to the right interval. So we're looking for 4. It looks like we're looking in this interval again. How's the derivative going to turn out? The derivative is going to turn out positive. So this would be a negative times this positive value, which means this would be a negative result, and this thing would be less than 0. So there's a little application of this thing in a little different form, kind of algebraic. Fast way to do it is take your derivative and then follow what the signs say to do.